Good morning. I'm Trisha G. I'm a developer advocate for JetBrains. I work mostly with IntelliJ IDEA, which means that it's kind of my job to stay up to date with what's happening with Java and kind of figure out what Java developers are doing in their day jobs. And so obviously one of the big topics for this year is going to be Java 9. Like, is it interesting? Do we care? What should we know about Java 9? What do we as Java developers, what are we going to get out of using Java 9? In this particular talk, I will also cover some of the specifics around IntelliJ IDEA functionality for Java 9. Normally, I try not to cover too much product-specific stuff, but it is the thing that most people ask me for, so it is a requested requirement. Who is an IntelliJ IDEA user? Who's an Eclipse person? Okay, people, more than one. NetBeans? Okay, and proud of it, I can see that. So feel free to tune out during the IntelliJ IDEA bits, but the rest of it is going to be general overview of Java 9 functionality for Java developers. Right, so I'm not an Oracle employee, so I don't have to put up a safe harbor statement like all the Oracle guys do. But I am going to talk a little bit about some of our plans for the roadmap. And, you know, plans change, and you can't really rely on it. And don't take anything I say as being a guarantee that we're definitely going to do something, blah, blah, blah. Java 9, let's just dive straight in there and take a look at Java 9. Amazing, Jigsaw, modularity. We're really excited about that in Java 9, right? No one in this room looks very excited about that. Every time people talk about Java 9, you hear about Jigsaw and modularity. It's been a long time coming. It's an important thing for the JDK. They want to have a modular code base that can be split down. You want to be able to deploy like smaller profile applications. But probably for the day-to-day developer, it's just not quite as exciting as perhaps lambdas and streams. And there is always this concern that maybe moving to Jigsaw, with some of the changes that that implies, our code might break, and I don't really care anyway. So maybe I won't use Java 9, maybe I'll just wait until some of the more exciting later versions of Java come out. But what I really want to point out is that Java 9 is a lot more than just Jigsaw. Obviously, you're going to hear a lot about Jigsaw because it has quite a big impact on what we do as developers, or it can do. But there are one or two other things in the Java 9 release. Only like 6 of those are related to Jigsaw. A lot of the others are interesting bits and pieces. Some are kind of under the cover stuff we're not going to use, but some of them are features that we as Java developers are going to use going forward. And what I want to do is, I'm not going to cover all of those because there are other talks at this conference and other talks available which cover a broader range of features. What I've tried to do is kind of pick out the features that I think are interesting for us as developers that we might start using on a day-to-day basis. So the kind of highlights, if you like. One of the other reasons to move to Java 9, apart from all these shiny new features, is better everything, obviously. That's probably what Oracle would like us to think. But we get better use of memory, improved performance in a bunch of different areas, a lot of work around some of the graphics side of stuff for Java, because we all use Java for graphics programming, right? Well, you know. Better use of hardware, CPU operations, better documentation, so we can create better documentation, but we also can look at better documentation, which I'll cover a bit later. Some better graphic stuff, faster compilation. So without using any of the features of Java 9, we will get some improvements. And you'll probably have already seen that every time we move to a new version of Java, we do get better performance out of the box. So let's just dive straight in there. What I want to do is I want to sort of tackle the elephant in the room straight away. If I compile my Java application, my Java 8 application, in Java 9, what is going to break? How hard is it going to be? So let's just go straight into that bit there. So what I have is, let's compile this. What I have is the application I was demoing last year and the year before to demo Java 8 features. I'm just basically going to compile it in Java 9 and see what breaks. And let's see, only one of these was something I put in there on purpose to break. The rest of it is stuff that is sort of genuine. In Java 8, so probably not a lot of people knew this, but underscore was a perfectly valid field name. And what people are starting to realize now that it's going to go away in Java 9 is people are thinking, oh, that sounds really useful. I might actually start using that. No, don't use underscore as a valid field name because it's going away. It was deprecated in Java 8. It's going away in Java 9. So what you want to do is you want to rename to something useful. And then that will go away. So that's fine. That's fairly easy. You probably weren't using underscores for variable names anyway. And I was using base64 encoder because I needed to do some encoding, and that seemed to be the right thing to do, even though I knew it was deprecated and I knew it was going away, and I was doing that thing that developers do and go, oh, it works, I don't care, I'm just going to carry on using it because it works. And now, of course, in Java 9, it's not there. I can't use it at all. I have to use something else. But it's fairly straightforward. The fix is fairly easy. You just have to say base64, java.util base64, get encoder, and in my case, I want to encode to string. So it's not quite a like-for-like replacement, but it does work. Get rid of my import. It doesn't work anymore. Rebuild everything. And then everything compiles. So granted, this is not a massive enterprise application. It's a fairly small application, but it's a real-world application. There were a couple of little bits and pieces I needed to fix to make it work in Java 9, and then it started working. There's a slight caveat to this. The original version of this application did use Gradle, and it was a multi-module project in Gradle, and Gradle doesn't currently work in Java 9 for multi-module projects. So I haven't quite figured out what's going on with that. I know they are on the case. They said it's going to be ready by the time Java 9 comes out, but currently, my Gradle version of this project does not build and compile. I also had some problems with Spock and Groovy tests, and I don't entirely know what the problem was there, but I did have some trouble with both Groovy and Gradle. So if you are using that, you might not be able to use Java 9 right away, but they are aware of it. I was using Gradle composite builds, and that works fine. And a Gradle simple build works as well. So it's just something that they're working on. So the latest release of Java 9 is build 161. I was using build 160 because I'm not a total idiot, and I didn't update to the most recent one this morning to have my whole demo crash and die. I'm sure it won't. I'm sure it'll be fine. But I have learnt my lesson in the past. So if you go, you can download the latest version of Java 9 and start playing with it straight away. This page, let me show you what this page is. This has loads of information about getting started with compiling against Java 9. So there's loads of stuff in here about like some weird things you might find, some edge cases, what to do if you find bugs, some help, support, frequently asked questions, that sort of thing. So if you do start playing with Java 9, I would highly recommend looking at this page, so that hopefully it will give you help without you having to bang your head against the wall. So yes, so your code might break, but the best thing to do, in my opinion, is to find that pain sooner rather than later. And there's a number of reasons for this. One, firstly, don't start putting Java 9 in production right now. That's not a good idea, okay? But it is a good idea to get a feel for how painful it may be for you to migrate to Java 9 sometime in the nearish future. So it's useful for you to find out for your applications. Two, it's very useful for the language developers in case you do find a bug, because they really would like you to find a bug now rather than after it's released. So it's useful for the language guys. And three, probably more interestingly, the library developers. So all the libraries that you're working on, all the frameworks that you're working on, like things like Gradle and Groovy, they're working hard to sort of catch up with the changes in Java 9, but they don't have as extensive a test base as like all the users out there using their libraries. So if you do find that something doesn't work or something doesn't behave the way you expect it to, you really could do with feeding that back to the library developers so that it helps the community as a whole and so that everything is kind of as ready as possible by the time Java 9 comes out. So yes, your code might break because there's a bunch of stuff that's going away. These are all the JEPs of things that are going away. So lots of deprecated stuff going away, obviously encapsulating the internal APIs that you're not supposed to use. Demos and samples, I hope your production code isn't dependent upon demos and samples, but all these bits and pieces are going away. So these things might impact the way that your code works. I think probably more interestingly is there are some JEPs which change some behavior which you may not realize your application is dependent upon. So one of the things that occurs to me, there were some changes around logging, and I'm wondering if there are some applications out there that grep log files for particular things, and maybe those things aren't there anymore. So I think that's one area that might be kind of interesting. Probably more likely is the fact that there's a new version string scheme. So it's not Java 1.8 anymore, it's Java 9. It's not 1.9. So I do know for a fact there are applications out there that sort of grep the version string to figure out what version they're running in order to figure out what to do. So if yours is one of those applications, you need to be aware that the version string is a different format than it used to be. So some little things like that probably not going to get caught by the compiler. So these are things that you need to run all your tests on to make sure that everything's working the way you expect it to. OK, so let's move straight on. That was kind of like what's possibly going to break. That's probably the thing we're most afraid of. But let's move on and take a look at Jigsaw, because that's the thing we're most excited about. All the Oracle people in the room just staring at me. You know, it's very exciting for you guys. So I want to get started on, I want to show you how to get started with a small, lightweight modular application, because I think for me, I've only really started looking at Jigsaw. And before I was like, well, if you're using modularity, you're probably already using Gradle or something else, or OSGI or something to create a modular system. And if you're not using modularity of some form, you probably don't care. But let's take a look at how you use Jigsaw and Java 9 modularity to create a modular application. So first up, I'm going to create a new IntelliJ IDEA module. I'm going to call it 1. And so IntelliJ has created this for me. I'm going to create a new Java class in here. Let's do this simple hello world type application. If we run that, this is obviously our simplest hello world application. So that kind of works. That's great. Let's put it into a package because it's a good thing to do. Let's move it into that package. And rerun that. So there's nothing magic about that. It's a simple hello world application. Let's turn this into a Java 9 module. And this is fairly easy. So in IntelliJ, you just say, create me a new module info.java. It will create a default module file, which kind of looks the way you expect it to. By default, IntelliJ will pick the IntelliJ module name to be the same as the Jigsaw module name, but I don't think it necessarily has to be. And then when I rerun my greetings file, it still works. Kind of under the covers, something you probably don't really care as much about, IntelliJ's figured out this is a modular system, so it's calling all the right class path things. So when you look at the quick start for modules, for example, you'll see you have to compile it from the command line with all these new flags and things. Now IntelliJ IDEA will just take care of that for you, and you've got a module path, and it knows that you're compiling it as a module, not using class path and not using the old way of doing stuff. So from our point of view, we've just created our first Java 9 module, and it was fairly painless. Of course, what we've got is the usual complaint of Java boilerplate. Our hello world application is 7 lines of code, and then we've added another file to it just because we didn't have enough code in there to begin with. So let's look at a more complex example, more realistic if you like. I've got something like, I have a class which is using Java util logging to output something instead. So we're not using system out. We get our warning, something happened at the bottom. OK, so that's fairly straightforward. What we're going to do is turn this into, or make a module info for this. So it's now modular. And then what we'll see is that when we go back to here, now we get strange red, it's not even a squiggly, the strange red code where our Java util logging apparently is no longer valid, which seems kind of weird because it's part of the JDK and we're using the JDK. We're not importing any dependencies. So why won't my code work anymore? Let's see if we can compile it and see what happens. So it tells me I have an illegal access error. So I cannot access Java util logging.logger in module Java logging. Fortunately, IntelliJ IDEA with magic Alt-Enter will fix this for you. So it says, add requires Java logging statement to module info.java. So if we look at our module info, now this module requires Java logging, and then everything will just work the way you expect it to. OK, so now we've created our second module with some dependency on a JDK module. The next thing I want to do is I want to show you our third module. And here, what we're going to be dependent upon is a class, another one of my classes. Let's minimize that. So in module 4, I have a person. It's just a simple person bean, really. And then in module 3, I want to print out that person. Now, I currently don't have access to that person object. Now, the first thing I need to do in IntelliJ is I need to add the dependency from the IntelliJ module 3 to the IntelliJ module 4. So that's the first thing I need to do. And obviously it'll take care of that. Add my import. And then this is still red because the next thing I need to do is I need for IntelliJ to give me the right, oh no, I know what I need to do. So I can't access this, I don't have access to the person. What I need to do over in module 4 is I need to say exports the package that person is in. So demo 4, I need to export that. And then in module 3, I can add requires for to module info in there. And then when I run this, everything works the way I expect it to. So getting started with modularity is really, it's not that tricky. So it's not quite as complicated as it was a few months ago when we had to sort of hand roll everything. There's a few caveats to be aware of in IntelliJ IDEA. A Jigsaw module has to correspond to an IntelliJ IDEA module and vice versa. You need to manage the dependencies between the modules in IntelliJ IDEA and in the JDK, in module info as well at the moment. So the support inside IntelliJ IDEA is only available in IntelliJ IDEA 2017.1, which came out yesterday. And the support is quite basic. So there's some code completion, there's some quick fixes, but not everything. It doesn't do everything magically for you. But it is fairly easy to get started with Jigsaw. So I highly recommend taking a look at it. It's not quite as scary as I thought it was going to be. So in 2017.1, which came out yesterday, so if there's an IntelliJ logo in the bottom, if you're not an IntelliJ user, you can just snooze for a couple of minutes, it's fine. In 2017.1, you get the generation of module info.java, which you saw me doing. It just generates one for you with sort of sensible settings. You get syntax support, so you get highlighting for requires and exports and opens and things. You get code completion, so you saw me type exports, and it suggested which package I might want to export. And it compiles, it works, which is a good thing, which it doesn't do in 2016.3. And there's quick fixes to add the correct sort of requires statements. In 2017-something, we've already covered automatic generation of module info.java. That came in 0.1. The other stuff was kind of in 2016.3, but then the language changed in build 159 and everything broke. So coming up in one of the later versions this year, we hope to be able to import a project which is defined with JDK 9 modules and import that correctly into IntelliJ modules without you having to do that manual stuff, and sort of keep those in sync as well. And we want to support JLink artifacts as well, but we haven't done that yet, but that's the plan. We really could do with your help because we really do create the features that are useful to our users. So if you want some particular features or you have some particular use cases, it's really important for us to hear about it. So this is the issue number of sort of the umbrella for Jigsaw support in IntelliJ IDEA. This was set to fixed yesterday. So we have the general basic support for Jigsaw, but off here you'll see links to loads of other features and bug fixes and issues around Jigsaw. So if you have any problems, raise an issue and link it to this preferably. If you have any suggestions, raise an issue, just let us know because that's how we're going to be able to evolve the IDE to support you. Next up, I want to look at the features which I think are probably going to be more applicable for us that we're probably going to use on a day-to-day basis. So like code features which are useful to us. There's new methods on the Streams API because Streams were really cool. We're starting to get the hang of it, probably. Who's using Java 8? Most of you, that's good. Who's an Android developer? Poor you, I'm so sorry. So we're starting to get the hang of the Streams API. The Streams API does cover a lot of the cases that we were kind of interested in, but obviously it's going to continue to evolve over time. And there are some things which were missing in Java 8. So let's take a look. For example, what I have here is I have a stream operation which takes a file. The file contains, for every line, it's like a JSON representation of a tweet. And the stream iterates over that file and then publishes the tweet on WebSockets. It's just a little server which is going to sit there and pretend to be Twitter. Okay? Now, the problem with this is that it's not really an infinite stream, but it doesn't terminate until it gets to the end of the file. And there's no way to wake it up and poke it and say, stop now, I'm done. So when I call stop on the service, it doesn't actually stop. It just kind of sits there and carries on forever. So I'll show you, because I have a test to prove this. So what it does, is it doesn't stop. What have I done? Oh, yes, OK, I know. I need to switch branches. So what it does is I start the service. I'm supposed to be stopping it. And then I wait 10 seconds for it to stop. But you can see it's still going. It's still ticking along. I can't stop the stream. It's just an infinite stream. And then it fails because after 10 seconds, it doesn't time out. And then I just kill the whole process. OK? So the new methods on streams will help me with this. What I can do, it might even be a tiny bit of a cheat, but it works. I can use the new method, take while, and then I give it some predicate to test to see whether I should stop or not. So keep doing this until some criteria is met. Now, normally, probably what you would do is test s to be some value and then stop it once it gets to some value. But I'm going to use my own thing. So I'm going to create a field. It's atomic Boolean. So I'm running. So while I'm running, keep taking something from the stream. And then when stop is called, I'm going to say, set this to false. So keep going until that sets to false. And then when I rerun, we'll see that when I call stop, it stops. It's done. Okay? So take while is a really useful feature for saying, right, do this stream thing until some criteria is met. It's really useful for ordered streams as well. So like take while, I don't know, let's say it's an alphabetical list, like take all the A's. While everything begins with A, keep doing something. And there's the sort of other side of that is drop while. So don't do it until some criteria is met. So this just kind of adds a really nice, useful feature to the stream operations. I can imagine you might want to do drop while and take while and combine them to like get something like in the middle of a stream as well. Oops. So what else have we got? We have convenience factory methods for collections, which I believe Stuart's going to talk about a bit more later on. So if you're more interested in this, go to Stuart's talk. So I think this is kind of one of the really nice things that we're going to use a lot of once we start using Java 9. Let me show you what I mean. Let's say we're trying to set up a list. This is test data in this particular case. Obviously, in the past, we would use arrays as list. Now we can say list.of. And you're thinking, OK, big deal. You just saved yourself 2 characters. So who cares? But it's not just list. We could already do that with list. But what we couldn't do is we couldn't do set of. OK? And that's kind of useful. So then we can do things with sets. We can create immutable sets and do stuff with it. Let's set that back to list. And what I think is much more useful is being able to do it with maps. Because this is genuine code that I had. I have to initialize a map of string values to moods, and in order to do that, I have to have this nasty static block, and it's kind of icky and evil, and I looked at loads of different ways of doing it, but this was the best way to do it. But in Java 9, it's not. I could say map of entries, and get rid of my nasty static block. I can use one of my favorite IntelliJ things, which is column select mode. Map.entry. Replace all of that with that. Get rid of this. And get rid of whatever I did there. Okay, so now I can do a map of entries. And then I can just kind of put those in. It's a lot easier. It's still a little bit, obviously you can do some static imports to reduce some of that boilerplate, so that's good. If you have fewer than 10, you can do something even simpler. And I can do map of, and then I can get rid of. All of that. And I can get rid of all of this. Okay, so it becomes a much, I'm going to get rid of this, by the way. This is parameter hints in IntelliJ IDEA. Go away. I don't want that. So now I can create maps in a much more succinct way. This would have been really useful for me when I worked at MongoDB, because everything at MongoDB is a key value pair, and we were always creating maps. And that's actually one of the reasons why we switched to Groovy for our testing, because the way to create maps was a lot neater. So this isn't quite as pretty as the Groovy way of creating maps, but it is a lot better than what we had before. So we don't have to do this nasty static thing and then put everything into the map. So I think this is one of the things for me which will make my life much more productive as a developer. Thank you, Stuart. It's fantastic. Million project coins. So Joe talked about this a lot more in his talk. So I really only want to cover the private methods on interfaces, because this is something that I think is going to be, well, I have found useful for myself. So what I had here is I had an interface with a couple of methods on. I could have put those methods on a class, but the class didn't really, it wasn't really a domain object, it didn't really have any state, so I just put a couple of functions on an interface. But of course, what you'll notice is that there's a lot of duplication here. Now, if you haven't been using loads of the Java 8 features, I think the first thing that people think is, why do I need private methods on interfaces? Because the whole point of an interface is to define the interface, the public API of something. So it seems kind of counterintuitive to have a private method. But with Java 8, now we have static methods on interfaces and default methods on interfaces. We have a lot more behavior on interfaces. They're a lot more chunky. So what we want to do is potentially be able to reduce the duplication in here. So if I extract this into a method, get field value, for example, previously this would have had to have been a public method which is accessible from everybody, and I might not want to do that. But now I can just simply turn that into a private method. So I think that's going to be super useful if you've started using things like static and default methods. You can kind of reduce some of your boilerplate and make your code a bit easier to manage. Updated deprecation. So I think maybe not that many people get excited about deprecation, but I was doing some library development, and when you're a library developer, it's really important to get deprecation right, because you really want to help people migrate from using some methods or some classes to something else, and merely marking it as deprecated and putting some documentation is not always enough to kind of poke people into the right direction. So what you can do in Java 9 is you don't just mark something as deprecated. You can also say when it was deprecated, so like, I don't know, version 9, it's a string, so you can put whatever value you want in there. And then you can say whether it's going away or not. So I think that's really, really useful, because you can say to some of your users, well, this is deprecated, but, you know, whatever. Or this is deprecated, and it's going away, do something about it. And you'll see this inside the JDK code. So for example, where's my example? So things like this. Deprecated since 1.2, for removal true. So like basically, as far as I'm concerned, that's those guys saying, don't use this. So this is a good thing. It's a good thing for language developers, but it's a good thing for us as users, because we can see these things and figure out like how important it is for us to migrate our code away from particular deprecated usages. Process API updates. So there's a whole set of things that I haven't had much of a chance to really play with yet, but I'll try and give you an idea. So you could do things like use this process builder to run things like the ls command, to do things like greps, to do things. I copied this code from somewhere else. I don't really know what it does. But you know, you can use the nice Streams API to sort of build up various operations and perform them. And I think for me, I know it sounds like the most stupid thing, but the ability to actually get the PID of your process is really, really useful. So I think particularly for people who might be managing their own services, they might be creating small services, and rather than kind of running in application servers or relying on some framework or library, a lot of people now are sort of like deploying tiny services, and they kind of want to manage some of this stuff themselves. And I think the new process API is going to help them do that. So I think this is really useful for a particular set of developers. More concurrency updates. Those are really helpfully named, Jeb. You just kind of put a bag of stuff in there. So this has got completable future in there and some other bits and pieces, but for me, the most interesting thing is the Flow API, so the support for the reactive API. Is anyone using any of the reactive frameworks like RxJava or Reactor or Akka? So a few of you, okay. So I think what's really interesting to me about this is that in Java 9, the API, the interfaces for these reactive implementations it's kind of baked into the language. And to me, that suggests that reactive programming is really here to stay. This idea of being able to listen to events and react to them rather than be doing like CRUD-style getter-setter type operations. So there's definitely a sort of a mind shift towards this event-driven type architecture. And now this is kind of as part of Java 9. Now, none of the libraries are part of Java 9, but the APIs are. So for example, if I'm a library developer, I can expose the reactive API and say, I kind of do reactive type stuff, but using the Java 9 interfaces, not having to depend on some other implementation. I'll try and give you a bit of an example. I have another talk, which will be available on video in a couple of months, which goes into this in more detail. But I'll just try and give you an idea. So when I created this code, I kind of had in mind that it was going to be a sort of event-driven, reactive-y type application. So I created an interface called Message Listener. And anything which was kind of listening to events was going to listen to Message Listener, implement Message Listener. So if I have a look at one of these things, then they have to implement on message. But what I might do now in Java 9 is instead of implementing Message Listener, I might implement flow.subscriber of string. Implement those methods. This on next is the equivalent of, let's take this up here, of my on message. So now, I'll call that item. So now my on message is now on next, which is implementing flow.subscriber. And also, the good thing is it forces me to think about these other things which are part of the reactive API, which is what do I do when I subscribe to something? Because I am a subscriber. What do I do when I am subscribed to something? What do I do when I get an error? What do I do when this stream of events has finished? So I have to implement those things as well. I've been playing a bit more with this for this other presentation about Java 9, reactive Java 9. I don't really recommend that you grow your own reactive implementation. It's not easy. But I would recommend that perhaps if you have some boundaries between services, for example, you might want to use the Java 9 Flow API, and then you can be implementing, between those services, you can be implementing it in RxJava, you can be implementing it in like the Spring Reactive or whatever, and the implementations don't matter. You can use the Java 9 Flow API to define those boundaries between your reactive services. So I think this is really interesting in terms of embracing reactive as like a really important programming paradigm that we're going to be using going forward, if you were not already using it. JShell. Okay, so let's talk a little bit about the REPL. There's another talk later on which I think goes into the REPL in a bit more detail, so I'm not going to cover it too much. Let's have a look. So IntelliJ IDEA doesn't have like an implementation of the REPL yet. It's kind of on the agenda, but it's not what we've done. Oops, JShell. What I'm doing is I'm using the terminal inside IntelliJ IDEA because this is Windows and the Windows command is kind of crap. So, so I'm using the terminal inside IntelliJ because it's a little bit easier because I can do things like, I don't know, copying and pasting, which is useful. And I can have it near my code so I can easily move stuff inside my IDE. So this is JShell, this is the REPL. I can do simple things like I can type hello, and it outputs hello and assigns it to some temporary variable. I can say 2 + 2, gives me the answer and assigns it to a temporary variable. Now, I've been doing Java programming for about 20 years. I haven't used a lot of other languages. I haven't used any languages that use REPLs. So this is like, oh, isn't this exciting? I don't know anything about REPLs, and it's not part of my usual workflow. So my demo is aimed at people who don't really use REPLs. So if you are a REPL person, you know all this stuff. You know how it works. One of the things to notice is that there's like a lot less ceremony than normal Java code. There's no semicolons. There's no assign this to a variable. If you want to, you can. So I can say int age equals 21. And now I have a variable called age. I can create methods. So I can say string name. And if I haven't finished my statement, it will just kind of expect me, can you really see that? It will just kind of expect me to carry on my statement like you would with a sort of SQL terminal. So I can return Trisha. Now I need a semicolon, close off my statement. And then I have a method called name. I can call that. One of the things which I was really excited about in a really silly way is I get tab completion inside the REPL. So I don't have to type everything, like, you know, a real IDE. So that's quite cool. What else? And if I've done something wrong, like, then it'll give me a familiar-ish compile type error. Okay? So that's quite cute. Is there anything else interesting? Oh, yes, and the REPL has sort of commands of its own. So if I type / and type tab, you can see, I hope, you can see all these different commands. So I can do things like I can see vars. So that's all the variables I've defined so far, these are including the temporary ones and my, the temporary ones and the ones that I've defined with a name. And I can do history. And that will show me everything I've typed. And I can imagine this being really useful for taking a look at all the operations I've tried to perform and maybe turning them into a script or into a more useful real class somewhere else. So that's the REPL. IntelliJ IDEA doesn't support it beyond kind of this level for the time being. But our vision is that it will be very much like the SQL console and the Groovy console. So the Groovy console, for example, you can do the same sorts of things. So you say, hello. You run it, you get the result. You can say 2 + 2. And you run it, and you get the result. So the advantage is, that might not seem like super exciting, but the advantage is that I can use my live templates inside my Groovy console. So all the stuff that I'm used to using inside IntelliJ, my code completion, my live templates, red squiggly lines, and so forth, I can get them inside the Groovy console. And the plan is to do something similar for the Java REPL as well. And the REPL has an API, so we should be able to plug into that, and we should be able to provide that functionality. And we intend to at some point. The other thing from an IntelliJ point of view is we have this idea of scratch files. So we can create a Java scratch file. And the idea is that obviously for other languages that aren't Java, you can kind of like play with it and run it and output it. If you try to do that with Java, let's say we do that, and it goes, oh no, you can't do that. We're expecting a class. I'm like, okay. So I have to do a class with all of the ceremony. I have to do a method. I have to do all of this. And you're like, well, I'm not entirely sure why I've got a Java scratch file when basically what I've just created is a class file. So, and even if I run this, it doesn't work, I think. Oh, that's because I've got a compiler error somewhere else. But it doesn't work because it's not in a file called Scratch. So it did work. I think this might be some of the Java 9 changes. So our goal is to plug the Java Scratch files into the REPL as well so that we can minimize a lot of this boilerplate and be able to run it via the REPL. That's kind of the plan. So some of the examples that I was showing there are from the REPL tutorial from the Adopt OpenJDK. This is really useful, actually. There's loads of stuff in there that kind of opened my eyes to what the REPL can do. Because it is kind of one of those flashing command line things. So it's not obvious what is available to you. So this gives you some hints as to what you can do. From an IntelliJ point of view, we'd really like your help around the REPL. If people are using it, if people have used REPLs previously and want to see the same sorts of features in the support in IntelliJ IDEA, this is the issue for what we're going to do with the REPL. I believe it just says we should implement something that supports the REPL. So any ideas, welcome, and any upvotes if you think it's really important, also welcome. Some other interesting bits and pieces around Java 9. Oh, right, so JEP 263, HiDPI graphics on Windows. This is particularly interesting to me because this is a Surface. It has a HiDPI display. IntelliJ IDEA has had to do an awful lot. The developers have done a lot to try and get it to be HiDPI, given that we code in Java on Windows. And with Java 9, we're going to use JEP 263 to be able to display IntelliJ in a nice high-definition way on Windows. HTML5 Javadoc. So you can generate HTML5 Javadoc. That's cool, right? Because everyone wants to do HTML5 Javadoc, I assume. And that's not by default, by the way. You have to pass in a flag to do that. So it just won't magically turn your Javadoc into something amazing and pretty. Javadoc search. This is actually one of my favorite features as well. I do have a lot of favorite features in Java 9. Because there's just lots of really nice little things which make life easier. So now this is the Java 9 Javadoc, and I have a little search box in the corner. Who knew that this sort of thing would be really useful? So I can type something, and I can actually search and go to stuff. Oh yeah, I turned off my Wi-Fi because I don't trust my friends. So I think that's really, really useful, especially for looking up things in the Java 9 Javadoc. And finally, I kind of mentioned this right at the beginning as well, but the default garbage collector is now G1. So I think people who really care about the performance, the details of the performance of their garbage collector have probably already tuned theirs by default, so probably don't really care about this. For people who don't care about garbage collection, the fact that it's now G1, they probably don't really care about that either, but it is a change in default behavior, so it's worth checking out and just making sure that nothing weird is going on with your application. So yes, oh wow, I've actually finished with a reasonable time. In summary, Java 9 is more than Jigsaw, and I personally think there are lots of really nice small features which just make our lives as developers really easy. New stuff on the Streams API, the collections, factory methods, the process API, all of these little bits and pieces are just going to make our lives a little bit easier. There's quite a lot to gain, so all those little tiny things for our productivity, performance improvements. I think modularity is going to be really good at helping us to think about encapsulation, good design principles, and things like that as well. There was potentially going to be some pain moving towards Java 9, so it's a good idea to find that sooner rather than later. I really think now is a good time to start playing. It's much more, the EA is much more stable, and it's a good time to figure out, like, before it's far too late, what could potentially go wrong with your code. All of the links that I've posted, the slides, other bits and pieces are all available at this URL. And of course, if you have any questions and stuff, you can always ping me on Twitter. And I actually have time for questions. Any questions? Yes?
So in terms of the deprecation stuff, I've got a couple of left IntelliJ questions.
Okay.
The deprecation is, there are plans to show it's slightly differently, but there's a for removal. I think it to be like at a glance to be able to know whether this is for removal or stuff.
So the question is, are there plans in IntelliJ to show when you're using a deprecated thing that's for removal slightly differently, more importantly, than a deprecation that's like, oh, you probably shouldn't use this? I actually don't know about that, but I think that's a really good idea. I think that's something that we could probably add quite easily, and I will make a note of that, because that's a good idea. More questions? Okay.
So you talked about adding support for modules to IntelliJ and then kind of natively understanding what you've got in code. How do you see that working in an environment where you've got, like, let's say Maven providing the module dependencies and you've got the Java 9 dependencies?
Yeah.
How are they going to mesh?
So the question is, how do I think IntelliJ specifically, but probably other tools, will really handle modules defined in Gradle / Maven, IntelliJ, and the JDK? That is such an excellent question. It's the very first question that I had. I don't know. I'm a little bit scared about how you get the interaction. If you're using 3 different module systems, how are they going to interact? And you're going to want them because you're going to want Gradle or Maven to manage your dependencies, to do your build. you're going to, obviously, you're going to want IntelliJ to understand what those modules are, and we're probably going to start using Jigsaw modules as well. So yeah, I don't know the answer to that, and it's definitely something that concerns me. But at the moment, from an IntelliJ point of view, our policy at the moment is when you're working within the IDE, the master is the IntelliJ module system. So what we do is we take all those other module systems and sort of convert them into IntelliJ modules and try and keep them in sync as much as possible. Any more questions? You've been a great audience. Thank you very much.